we would like to find the image of the line segment given by real part of z equals -1 and imaginary part of z is strictly between pi over 2 and 3 pi over 2 under the mapping w equals f of z equals e to the z. So e to the z is e to the x plus iy, which is e to the x times e to the iy, which is e to the x times cisy. So this is a polar form. E to the x is our polar radius, and y is our polar angle. Now, real part of z equals -1 means x is equal to -1. And the imaginary part of z is between pi over 2 and 3 pi over 2 means that y is between pi over 2 and 3 pi over 2. So our polar radius, w equals e to the -1. Our polar radius is e to the -1. And our angle is y, where y is between pi over 2 and 3 pi over 2. So our radius is e to the -1, which is 1 over e. And according to my calculator, that's approximately 0.37. So we have a little radius here. So we're going to have a semicircular arc of this radius centered at the origin, and the angle in the semicircle is going to go from pi over 2, 90 degrees, to 3 pi over 2, 270 degrees. So in the z-plane, z has the real part is -1, so there's -1, and the imaginary part is between pi over 2, which we'll put here, and 3 pi over 2, so that'll be pi over 2 times I right there, and this one would be 3 pi over 2 times I. So we're talking about this vertical line segment here is our domain, and then the image under the map w equals e to the z in the w plane, where the axes are called u and iv, is a semicircle with radius 1 over e and angular component from pi over 2, which is here, 90 degrees, to 3 pi over 2, which is here. So our angular component, we have is here. We have a semicircle centered at the origin of radius 1 over e. So to indicate that, this is the real number here, -1 over e, and this number at the top here would be 1 over e times I, and this one would be its negative. So this is the image. This vertical line segment is turned into this semicircular arc by the mapping w equals e to the z, the exponential map.